Okay, so just looking at the first problem from our homework, similarity of right triangles, we need to come up with our three similarity statements for this triangle. And so to do that, just as a reminder to everybody, we just simply take one of the acute angles from our big right triangle.
What'd you have, Ann?
Just mark one of the acute angles as a single, mark the other acute angle as a double mark. And so then if we look at one of the smaller triangles, like this one, we see that it already has a right angle. It already has a single marked angle, so this must be the double marked angle. And if we look at the very small triangle, that one, we see it already has a double marked angle, it already has a right angle, so then this must be the single marked angle. And so that means, and also we could redraw these, see if I can do that fairly well. So we have the big triangle, JLK. We have the gold triangle, which is JNK. And we have the green triangle, which is KNL. And so we know that triangle JLK is similar to triangle JKN and similar to triangle KLN, all by angle similarity. That then translates to these other problems where we're solving for variables, such as, let's take a look here at number 8. Looking at number 8, again, we want to go through and mark the acute angles of the large triangle with a single and a double. And so now that triangle has three angles, a single marked angle, a double marked angle, and a right angle. So if we now look at the small triangle on the left, which of course is this one, we see that it has a single marked angle, a right angle, and so this must be the double marked angle. That is because of the third angles theorem. If you take a look at the small triangle on the right, the green triangle, it already has a double marked angle, it already has a right angle, so this angle up top must be the single marked angle. And so now what we want to do is we want to redraw the information from our triangles. So I'm just going to go ahead and draw all three. Technically, you've only got to draw two of them. And my stylus makes it all squirvy, I'm sorry. Technically, you've only got to draw two of them, but I'm going to draw all three this time. Electronic styli don't like to draw diagonals. All right, so there's my three triangles. The big triangle has the side lengths x, y, and 20. The gold triangle, its hypotenuse is y. We don't know the side opposite the single mark, but we do know the side opposite the double mark. The one between the right angle and the single marked angle, that is 16. Because notice, over here we have 4, and if the whole thing is 20, then from R to V must be 16. And now looking at the small green triangle, the hypotenuse is x, and the side between the right angle and the double marked angle is 4. So there's all of our information. So now what we need to do is we need to take those three triangles that we know are similar, and we need to set up proportions. So I am going to first look at the fact that I have y corresponding to 20 in my first two triangles, and this 16 corresponds to a y. So I can set up a proportion with y's. So 16 and y, I'm taking that information from this triangle. And so now 16 corresponds to y in the first triangle. So I put y right there. Y corresponds to 20 in the first triangle. So I'm going to put 20 right there. I want to cross multiply. So if I cross multiply, I get y squared equals, now I'm going to write this out separately as 16 times 20. That actually shortcuts my work, because you guys know my next step is to take the square root of both sides. I saw that 16 was a perfect square. So I can automatically say that I've got the square root of 16 times the square root of 20. The square root of 16 is going to be 4. We got that. But now, is the square root of 20 reduced? No. What can I factor out of that? What's the biggest perfect square that comes out of 20? It's 4. Absolutely. Yeah, don't be afraid to talk during a video, guys. They can't hear you anyways. All right? So 4 is the biggest perfect square that can come out of 20. So we're going to say y equals 4, that's from the 16, right? Times the square root of 4 times the square root of 5. That's breaking apart the square root of 20. Well, the square root of 4 is 2. So we have y equals 4 times 2 times the square root of 5. And so our answer, y equals 8 square root of 5. That's the answer for y. Okay, well, we need to do the exact same thing for x. And so looking here, I do know what y is now, but I'd rather not use something I just found, let alone the fact it's kind of nasty. I don't want to work with it if I don't have to. Okay? But I see that x corresponds to 20 from the first triangle. And I see that this 4 corresponds to x in the first triangle. So I can write a proportion for x. So taking the information from that last triangle there, I have x and 4. All right, that's just the information from this triangle. So now x corresponds to 20. I'm going to put a 20 there. And 4 corresponds to x. So I'm going to put an x there. Again, I cross multiply. So I get x squared equals, and again, I have a perfect square already. So I'm going to just leave it as 4 times 20. You can go ahead and write 80 if you want, and just have to reduce down the square root of 80. That's okay. All right, but again, I'm trying to shortcut our work a little bit, make it a little easier. So I take the square root of both sides. X equals the square root of 4 times the square root of 20. But we know that the square root of 20 is the square root of 4 times the square root of 5, because again, we've done that already from the previous part. And so we have 2 times 2 times the square root of 5. So x equals 4 square root 5.